Hey everybody, this is Mr. Munson, and we are continuing Unit 9, Logic and Reasoning. Today we're going to be looking at Section 9.3, Deductive Reasoning, Compound Statements, and Venn Diagrams. So we're going to be looking at a series of statements like those below. We could turn that into symbols using one letters, two letters, whatever, with the Venn symbol in between it. We're going to look at how to process multiple statements like that in this video. Hey, this video goes out to a student in my second period that said Brussels sprouts is, okay, no one's ever said Brussels sprouts is their favorite vegetables. So you don't need to put this video on pause and look at Brussels sprouts. We're moving on. All right, let's just do a real quick review of some of the things that we've talked about. Make sure you're up on the vocabulary. Statement. We have different kinds of statements that we can make. We can have or statements and statements. If you remember upside down, this means the or symbol. This way is the and symbol, right? So we might have something like, I go to the store or I do my homework, or I go to the store and I do my homework, and that would be the symbolic form for that. So those previous forms were a combination of a couple of different statements into and or statements. Just a basic statement, let's just say a P, we could talk about a statement P, it's cold outside. And then we talked about being able to write conjectures like, okay, so I know it's cold outside, so what would be a conjecture that my students wear coats today? That would be a conjecture. Knowing that information, that it's cold outside, I could write a conjecture of my students are wearing jackets outside. Now, it might not be true all the time or whatever, but it's just basically, it makes sense to make that statement given the fact that it's cold out. Then we have conditional statements. Conditional statements take of the form P then Q. If P happens, then Q happens. Those are typical ways that we say it. And let's take a look at Venn diagrams. Now, you've been doing Venn diagrams for a while. Just basicness is like we have a circle like this, and this might represent all the parallelograms in the world, right? All the different ones that we could write. And I could draw a circle here and say this represents all the rhombuses. And all the rhombuses, there's no rhombuses outside the circle of parallelogram because every rhombus falls into the category of a parallelogram. So in the world of parallelograms, there are some rectangles. Of course, all the rectangles fall into the category of parallelogram, so there's none sitting outside here at all. But kind of interesting is that we have this overlap between rectangles and rhombuses. So your question at some point in this video is to figure out, what do you call that overlap? What are the kind of shapes would fall into that category of being in the circle for rhombus and that circle for rectangle? Okay, the first thing, big thing that I want you to catch here is property. This property is called the Law of Detachment. So we're given this series of statements. One's a conditional statement, one's just a regular statement. It says if P happens, then Q happens. Well, the next one is that P happens. That's what that would represent. And if that is the case, then the law of detachment allows me to come to a conclusion that Q happened. Okay? So these little stack of balls over here represents the word then. So this is the law of detachment. Okay? Given this information at the top, given this series, this conditional statement, and then a statement saying the first thing happened, then we can say the next thing happened. Law of detachment. So here's a statement. Let's see if you can figure this out. If it snows, then it is cold. Hey, it snowed out. Using the law of detachment, see if you can come to a conclusion. Put me on pause and check your answer. So hopefully you wrote the little balls, the little three balls there stacked, saying basically the word then, that's the symbol for it. Then it is cold, okay? So this would be your conclusion, it is cold. Hey, let me just take a quick second and remind you that the hypothesis is this first part. Remember, we do not include the if. And the conclusion of this conditional statement is the last part. We do not include the then. All right, here's another one. Give yourself a shot at this one, see what you get. Put me on pause. All right. Hopefully you wrote the conclusion of I get 15 talents. A completely nonsense statement. And a lot of the statements that I use in my my practice like this is nonsensical statements so that you're focusing in on the process of looking at how pieces go together. So what happened was the first thing, right? This thing matches or is close to what the first thing is. Since that happened, then I get to conclude the last thing happened, okay? There probably should be the word then in there. Take a look at this conditional statement and then a statement saying something happened. See if you can come up with a conclusion for this one. Put me on pause, come back and check your answer. Okay, hopefully you said not this, okay? P is the #1 wrong answer to this question. Here's the reason why. I'm told the last thing happened. For me to conclude that P happens means I have to go back against the arrow. The arrow's pointing in this direction for a reason. It says that if P happens, then Q happens, not the other way around. An example of this would, if it's a square, then it's a parallelogram. Hey, I've got a parallelogram. See, the second thing just happened. Hey, I got a parallelogram. I can't conclude backwards in that I have a square. Okay, it doesn't work that way. Okay, here's the law of syllogism. As you can expect, having two laws close to the same name, you might mess these up. It's going to be really important you understand the difference. Maybe set up flashcards, whatever you have to do. The law of syllogism basically says this. If I'm given a series of conditional statements like this, where the last thing matches the first thing of the next line, then I can write a conclusion. And it basically shortens this down to the conclusion that if P happens, the first thing, then the last thing happens. Okay? That parentheses shouldn't be there, of course. That's the law of syllogism. All right, notice that in the law of syllogism, the conclusion, what I'm going to write as an answer, is a conditional statement. In the law of detachment, it's something happened. Okay? Here you go. See if you can do this one. Put me on pause. Come back and check your answer. Sorry, I had to show you the second series of conditional statements to get the thing set up right. Hopefully, put me on pause again if you haven't done it. All right. So basically, what I do is I find the first part and the last part and put them together, but only after I check and confirm that these two things match up. Okay? If the shape, oops, I'm sorry. If the shape is a slurp or slope, that matches. Okay? Those things have to match. Then I can take the first thing, the last thing, put it together as a conditional statement. Let's try to. So here you go. This just represents a series of conditional statements, real words, real sentences, just distilled down into a shortcut. So same property, everything happens. Put me on pause, check your answer. All right, I've confirmed that the last part of the first statement matches the first part of the second statement and so on. So what would be my conclusion? T then P, right? If the first thing happens, then the last thing happens. This example is kind of a combination of using the law of detachment as well as the law of syllogism. The law of syllogism allows me to take the first three statements and see that in fact they line up good, right? The last is the first. The last is the first, and so I can kind of piece these things together. Then the law of detachment says, hey, the first thing happened, so now I get to conclude the last thing happened. So now K could be a series of words like I went to the store, or I got kicked. I got kicked would be a conclusion. Instead of writing K happened, I might write the actual sentence or the statement, I got kicked, All right, let's just make sure real quickly that you know when you can't make a conclusion, okay? So here's an example. I got P then Q, and I'm telling you Q happened. What would be your conclusion? Put me on pause and see if you can come back. Check your answer. I hope you wrote that nothing other than Q happened. right? There's no conclusion. Saying P happened means you're going against the arrow. That can't happen. All right, here you go. If a polygon is a square, then it's a parallelogram. Hey, it's a parallelogram here. Write your conclusion, and then come back and check your answer. Once again, this is just like the one I just did. None. I can't come to any conclusion other than I have a parallelogram. How about this one? Put me on pause. Come back and check your answer. All right, there we go. Again, no conclusion. Um, these two look similar, and you might be tempted to negate the second one to get it to work, right? So if I go through and negate both things, this becomes a K, then not S. And now they match, but you can't do that. We could be learning some things where some tricks like that. Right now we're not gonna. And so basically, with the given statements as they are, there's no conclusion. You can't piece that thing together. All right, so take a look at this Venn diagram. It's basically a big circle. That circle represents all the Q's. That little circle represents all the P's, whatever these things are, squares, rhombuses, going to the store, statements like that, okay? So that kind of Venn diagram can be written as an if-then statement. See if this makes sense to you. This says if it's a P, then it's also a Q. Doesn't that make sense? If it's a P, then it's got to be a Q, okay, because it's sitting in that category, okay? But if it was, if I had this Venn diagram here, and I said, no, actually it's the conditional statement. If it's a Q, then it's a P, the converse of what I have there in blue. That's saying that if it's a Q, then it's got to be a P as well. And that's not the case, because I can come up with all the things out over here that have nothing to do with P. Make sure that you can look at a Venn diagram like that and write a conditional statement for it. All right, here's your hand at writing a Venn diagram given a conditional statement. See if you can do it backwards. Put me on pause, come back and check your answer. Which one is it? It is just like that. All right, hopefully you got that one right. It makes sense. If it's a rectangle, it's got to be a parallelogram. All right, so here you go. Write the word that best describes the yellow region in this Venn diagram. So you have a circle represent all the rhombuses in the world and another circle that represents all the rectangles in the world. What's the yellow? Where the two meet? What would you write there? Put me on pause. Quickly put that in your notes. See if you're right. Hopefully you said square. See if you can predict. Go ahead and write this shape. I shrunk it down. You can do too, right? Just redraw it smaller. But I have a circle now, a red circle. What do you think the name of the things are that the red circle represents? Put me on pause. See if you can come back and do this. It's the parallelograms, right? Rectangle, rhombus, and squares are all parallelograms, so it falls into that category. Let's play this game, see if you can come up with what the black box means. Hey, if you got quads, you got it right. You totally understand it. See, quads are the big idea, and parallelograms fall into that. So can you think of a shape that would sit in the quadrilateral field of play, if you will, but would not touch the parallelograms? Trapezoids, right? Inside the world of trapezoids, there's another subset as they said, and that would be isosceles trapezoids, right? How about, can you come up with another one, another shape that fits in this world over here? Again, it doesn't touch trapezoids, it doesn't touch parallelograms. What kind of shapes would that be? If you got kites, excellent job. And so all the area outside these circles, all that blue area there, that kind of light blue area, those would be all the quadrilaterals, all the four-sided figures that are not trapezoids, not parallelograms, and not kites. There you have it. There's your try it problems. I'll take a few seconds and scroll through in a bigger format for those people looking at a smaller device. Fantastic. Have a great day.